In the last video, we talked about how to convert from degrees to radians, and essentially we said that the conclusion to that is that in order for you to convert from degrees to radians, just multiply by pi over 180, right? I spoke a lot of words, but essentially this is the conclusion. Multiply by pi over 180. The reverse conversion, which is radians to degrees, is the exact opposite of this conversion, right? So we're going to start this time with the summary, right? Just so that if you are impatient, you don't want to go through this whole thing, I'm going to summarize it at the very beginning, right? So to convert from radians to degrees, multiply, oh, horrible. Multiply by 180 over pi. Now let's talk about why, right? So we started off by talking about the fact that we know that 360, this is from our very first video where we introduced the radians. We know that 360 degrees is 2 pi radians, right? So what we're going to do is now we're going to say, okay, if 360 degrees is 2 pi radians, then that means, let me just write it like this. 2 pi radians is equal to 360 degrees, right? So that means we're going to take, for example, what's pi radians? All right, so this is the simple one, right? So pi radian, and we should know from the last video that it should be 180, right? So what's pi radian? What's pi radian in degrees? So now we're going to call this theta. What is this value of theta? What is the equivalent of pi radians in degrees, right? So what we're going to say is, okay, we started off with 360 divided by 2 pi, right? 360 degrees over 2 pi is our conversion from degrees to radians. This ratio should be exactly the same as whatever angle we're looking for, because this is in degrees, divided by the angle that you've been given in radians, right? So all we're saying here is we have the first pair, and this is the degree value, this is the radian value. The second pair that we're looking for should also follow exactly the same ratio, right? We should have degrees over radians. These should give us exactly the same ratio, right? So this is how the ratios work. The first ratio that you're given should equal the second one, the second pair, which contains the thing that you're looking for, right? So, and the reason why I put degrees on top is because degrees is things that you're looking for. So it's kind of easy to move the one that you know at the bottom, because now you can multiply both sides as we're about to do, right? So let's just rewrite this. So this is going to be 360 over 2 pi, which can be simplified, right? This can be simplified because 2 goes into itself once, and then 2 goes into 360 180 times. So this actually can be rewritten as 180 over pi, right? Which is that conversion that we talked about before, right? So that's why we use 180 over pi instead of 360 over 2 pi, because it's just a simplified version. Is equal to theta divided by pi. So now we can multiply both sides by pi to isolate our theta. All right, so multiply this side by pi. It cancels on the right hand side. So on the left hand side, what you're left with is pi. Actually, before I do that, let me just switch these. So your theta is equal to pi multiplied by 180 over pi. And this is that summary that we talked about, right? So the angle that you are given in radians essentially is this. This is the unknown value. This is the radian value that you're looking for, that you're trying to convert rather. This is your conversion. So just take that value in radians, multiply it by 180 over pi. Simply, that's all you just need to do, right? So now let's continue. So pi goes into itself once, it cancels with this one at the bottom. So all you're left with is theta is equal to 180 degrees, which makes sense, because that is the conversion that we've been looking for, that we've been using this whole time, right? We know that pi is equal to 180, and we've just figured that out from this conversion. So we know that this is great, right? But now let's look at a couple more examples here. So example number 2. For this example, we're trying to convert pi over 3 radians to degrees, right? You could just multiply that value by 180 over pi, right? But we're going to take the long way yet again, right? So the long way is, we know that pi, or at least, yeah, pi radians is equal to 180 degrees. Let me just put the units. Therefore, what is pi over 3 radians equal to? It's going to be equal to value theta, which we don't know. So we're going to say, okay, my ratio of 180 over pi is equal to, right, because this is the first pair, right, your degrees over your radians, is equal to the degree over radians of this pair, which is theta over pi over 3. Right? Again, the reason why I'm going degrees over radians is because I want this degree value to stay on top, because algebraically, right, solving that equation is going to be easier if my unknown value is on top. If it's at the bottom, I need to do a little bit more, need to do some matrix. So it's easier this way. So now we multiply both sides by pi over 3 to get this value to the other side and isolate my theta. It's going to cancel on this side, but now remember, we need to multiply on both sides. So now all we have left is theta is equal to this multiplied by that, which again is just our conversion. Pi over 3 multiplied by 180 over pi. Cancel the pi's, right? 3 goes into 180 60 times. Therefore, your theta value is equal to 60 degrees. Right, one last example. This time, we're not going to use something with a pi in it. What we're going to do is we want to convert 2 radians to degrees. All right, so we're going to use exact same conversion. Or literally, what you could do if you're in a time crunch, this is an exam, all you just need to do is theta is equal to, take this, multiply by a conversion, which is 180 over pi. Right? Let's say in this exam, you're under pressure, you've completely forgotten what the conversion is. You can't remember if it's 180 over pi, you can't remember, or if it's pi over 180. So you calm down, right? You break it down, right? So we're going to break it down. So we know that pi radians would convert to 180 degrees. So what would 2 radians convert to? It will convert to a theta value, which we don't know. So the ratio of my 180 over pi should be the exact same as the ratio of my other degree angle, which is theta, divided by my radian, which is 2. So now we're going to multiply both sides by 2. This would give me theta. I'm just going to rearrange this. This is 2 multiplied by the conversion over pi, right? So now this is going to give me 2 multiplied by 360. 2 multiplied by 180, which is 360 over pi. At this point, if they want you to keep it an exact value, you can keep it like this, because you can't really simplify this any further. But you could also throw it into your calculator. 360 divided by pi gives us 114.6 degrees. All right. Here's a couple of questions that I would like to answer, right? So just because I know I'm following the exact same steps every time, but what if you forgot that this was degrees over radians? Does it matter? It really doesn't, because even if you go pi over 180 here, as long as you remember that if you put the radians on top on this side, you have to put the radians on top on that side. So whatever value you got here, which was your 2, now has to go to the top, and then your degree value goes to the bottom. As long as you don't mix. If your radians on top on this side, you can't put the degree value on top on this side, right? Just make sure that if you've put radians over degrees on the left, it has to be radians over degrees on the right, and then vice versa. If it's degrees over radians on the left, it has to be degrees over radians on the right, because what we'll just do with this is we'll just like multiply by theta, this cancels, so this becomes, depending on how you like to solve your your equations when you're trying to like solve for the denominator of one side. So this could become pi theta over 180 is equal to 2, right? And then what you're going to do is you're also going to multiply by 180 over pi, because it will cancel these 180s, it will cancel this pi, but remember you have to then move it to the other side. So now if you multiply 180 over pi over here, you multiply 180 over pi over there, it brings you exactly to the same place, right? So you're good, right? So it's fine. Here's a hack that if you, let's say again, I'm going to bring you to that first step. You've gotten to this stage. You just want to multiply whatever value you've gotten by a conversion to get the answer. Remember, with its degrees to radians or radians to degrees, your conversion is always 180 over pi, or the inverse, pi over 180. Now, 180 is a much bigger value than pi, right? Which means if you're multiplying 180 over pi, you are going to get a big value, right? The reason why I say that is because degrees are going to be bigger than radians. So 2 radians equates to 114 degrees, right? So your degrees are much bigger. So the reason why I'm mentioning all this is if you've forgotten if it's pi over 180 or 180 over pi, you can just say, okay, if I'm going from radians to degrees, I'm going from small to big. So if I'm going to the bigger value, then I need to multiply the bigger conversion, which is 180 over pi. This is a much bigger fraction, or this fraction is a much bigger value than this one. This goes from small to big, right? This one is a small value because pi over 180 is a very small fraction. 180 is going to be really big. So that means this converts from big to small, right? So all you just need to do is, okay, if I'm going from two radians, I know I should get, if I'm going to degrees, I know my answer should be a really big value. So I just multiply by the big conversion, which is the 180 over pi. If I want to convert, let's say 100 degrees, if I'm going to radians, I know my radian value is going to be small. So maybe let me multiply by the small conversion, which is going to be pi over 180, right? If your answer is bigger, if you're going from degrees and your answer is bigger than when you started, right? If your radian value is bigger than your degrees, you've used the wrong conversion, if that makes sense, right? So that's just a hack, but, just in case once you get, you can do all of this stuff once you get really comfortable with the work. But for now, until you get comfortable, just follow these steps, right? Or make sure that you memorize the conversion. But those are just a couple of hacks that you could follow, especially for your exam when you're now working on time. But yeah, okay, perfect. So I hope all of this made sense. In the next video, we're now going to get into work about the trigonometry, right? So how to do trigonometry problems with radians. So I hope I see you there, and I hope this video makes sense.